Alright, so what we're going to be looking at today are types of equations that we can have and what types of solutions we can get. So we're going to start off on page 103 with complex conjugates. So we've talked about conjugates a little bit before, but not complex conjugates. Complex conjugates would just be if we have A plus BI, the complex conjugate of that would be A minus BI. So the A, the B, the I, that stays the same, and we just want to change that middle sign. So when the middle sign's a plus, the conjugate would be a minus. The reason we care about this is because of what you will see if you flip the sign over to the page over rather to 104. The complex conjugate theorem. It says this: if f is a polynomial function with real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a zero of f. So if I told you that 2 is a zero, and then I also told you that 3 plus 2i is a zero, what else would have to be a zero? There would have to be one more zero based on what we just said. What would it have to be? Yeah. Right. So 3 minus 2i would also have to be a zero. So now, let's go ahead and finish this. If we know that these are our three zeros, and they want us to come up with the polynomial function for this. So we're working backwards. These are the zeros. What's the polynomial function? What would be the factor for this one? Say it louder. Did you say it, Natalia? X minus 2 is the factor. X minus 2 is all we have to put. For these two, if I want to find the factor for this, these are two solutions. So I want to try using this x squared minus the sum x plus the product. Because that is going to tell me what function has these solutions. In other words, what was the factor that produced these zeros? So to figure that out, I've got to find the sum here. So to find the sum, I only use 2 at a time when I'm going to use this formula. Some of you were trying to find the sum of all three. You can't do that. When you're going to use this, you can only use 2 solutions. And the 2 obvious ones to choose are these 2. We already know the factor for this one. So Maya, what's the sum? If I add those 2, what do we get? For the product, it's a little bit tougher to do. I have to do 3 times 3 is 9. The outers are negative 6i. The inners are positive 6i. That's going to be negative 4i squared. What is negative 4i squared? Charlie? So I'm going to have 9 plus 4, so that's going to give us 13. So here's our sum, here's our product. Plug those in now. What's that quadratic factor going to be that would cause us to have those solutions then? Here we go. Good job. So there would be our function in factored form. But we don't just want the function in factored form. We want it all multiplied out. So now we would just have to keep going. X times x is x to the third minus 6x squared plus 13x minus 2x squared plus 12x minus 26. Combining my like terms, I get this. So I did that pretty quickly. Maybe I want to check. Well, a good way to check would be to go to y equals, type this thing in that I just got. You don't need to do this, just kind of watch. I'm just going to type that in, and I want to check to see if that is a zero. What should be the zero that I should get here? 2. See, I'm not going to see those other zeros, those imaginary zeros, but I do see 2, 0. That's a good sign. If I look at it, 2, 0 should be my only real zero. See how it is? The other zeros are what types? What types of zeros are these? Imaginary. So we don't see those as zeros crossing the x-axis. So therefore, we know that this is probably the correct answer. Okay? All right. So now let's look at some other rules. Another thing that was very interesting to early mathematicians was this right here. We've talked about this enough that I'm just going to say it very quickly. Whatever the degree of our polynomial is, that's how many solutions we're going to have. I'm not going to read through all of this. We also do have to count it as repeated. For example, if I gave you this function, I have to have 5 solutions, but some of them might be repeated. So we would have a total, though, of 5 solutions. Some can be imaginary, some could be positive real solutions, some could be negative real solutions. These are the 3 types of solutions that we can have: imaginary, positive reals, or negative reals. Sometimes they occur, it could be a solution once, or twice, or 3 times. Like if I have this function, f of x equals x minus 2 to the third, well, if I set that equal to 0, I take the cube root, I get x minus 2 equals 0, so x equals 2, but how many times is that a solution? How many times, guys? What's the power there? 3. So this would be a solution 3 times. Let's write it just like this. So that is a solution 3 times. Because it's really like this. It's like x minus 2 equals 0. It's x minus 2 equals 0. And it's x minus 2 equals 0. Because I have 3 of them. Do you see what I mean by that? All right. So I talked about the 3 types of solutions we can have. There are 3 types once again. Look over here at page 101 for a minute, and I'll show you an example of this. Look at this right here. I can see right here, that would be 1 positive real 0. But look at all of these functions that they gave us. All of these are cubics, so how many solutions altogether do they have to have? 3. This only shows me 1 positive real 0. So there will probably be 2 imaginary zeros. Look over here. How many positive real zeros do I have? That's a positive answer, that's a positive answer. So how many positive real zeros does this one have? 2 positive real zeros. And then how many negative real zeros? And so how many total should we have? 3, and we do. Okay? Whereas let's take this one, for example. This will be the last one. What kind of 0 is that? Negative real. So we have 1 negative real. So what does the rest of them have to be? 2 imaginary. Very good. Okay? Now, that leads us then to page 104. I know we have to skip around quite a bit here, but it makes more sense this way. There was a mathematician called Descartes, and he came up with this rule of signs that he noticed in math. What he noticed is if we're given a function, a polynomial function with real coefficients, the number of positive real zeros, like we just looked at on the graphs, is equal to the number of changes in sign of the coefficients of f of x, or is less than this by an even number. Sounds confusing, but once you see it in action, it's really not. Let's say we have this function, x to the 4th minus 2x to the 3rd plus 3x squared minus x plus 1. Read it again. The number of positive real zeros is equal to the number of changes in sign of the coefficients of f of x. What's this sign here, positive or negative? Then what's the next one? Did we change? That's 1 change. Are we changing here? 2 changes. Are we changing again? 3. Are we changing again? 4. So we had 4 changes. So that means we could have 4 positive real solutions, or zeros. Solutions and zeros means the same thing. But it also says, or we could have less than this by an even number. So I could subtract 2, and maybe I'm only going to have 2 positive real solutions. Or I could subtract another 2. I might only have 0 positive real solutions. Could we have exactly 3 positive real solutions? No. Descartes' rule of signs says we're either going to have 4, or we're going to have 2, or we're going to have none. One of those has to be true. The second part of his rule says the number of negative real zeros is equal to the number of changes in sign of the coefficients of f of negative x. F of negative x means we're going to take each of these x's and replace them with a negative. Everywhere I see an x, I'm replacing it with a negative x. And now I'm going to simplify it. Negative to the 4th becomes a positive. A negative to the 3rd is negative times a negative is a positive. A negative x squared is a positive times a positive is a positive. A negative times a negative is a positive, and a positive. So when I plug in a negative x, this is what I end up getting. Do I have any changes in sign? No. So I will have 0 negative real solutions. On your homework, they might give you a function like this and say, is it possible to have exactly 1 negative real solution? What would your answer be? No. Correct. No is the right answer. Now, we're going to make this chart now. We can have either positive reals, we can have negative reals, or we can have imaginary. Those are the 3 types of solutions we can have. We could have 4 positive reals. We're only allowed to have 0 negative reals. How many imaginaries if we have to have a total of 4 solutions? 0. That's my only option there. I could also have 2 positive reals. How many negative reals are possible always? 0 here. Didn't it say 0 right there? So how many imaginaries might we have? 2. We could have 0 positive reals, always 0 here, and how many imaginaries might we have? 4. Those are the only possibilities. So if I now were to graph this, and again, you don't need to graph it, just kind of watch. We're going to look at this graph and we're going to see what the solutions actually look like. Here's the way the function looks. What did it end up being then? Which of these was it? First, second, or third? Third. It ended up being this. So Descartes was a pretty smart guy to figure that out. But that's something that you will be asked on your homework. Alright. So now let's do a couple more problems. Let's now look at page 105. And let's do number 1. And we're just going to do number 1, and then I'm going to talk a little more about Descartes. That's all we're going to do from this section. So I'm looking at this problem. I'm thinking about all the options that I could have. I could have solutions of plus or minus 1, 2, 3, 4, 5, 6, 10, 12. I mean, there's so many possibilities, aren't there? If I were to list them using that P over Q method, I don't even want to mess with that. So here's what I'm going to do instead. You might want to do this along with me. mistake somewhere. Yeah, there we go. That's a plus. Okay, so I fixed the plus. That's stuck in there now. So now I'm going to look at my graph again. And I can see that I actually do have one real negative solution and one real positive real solution. But I want to know exactly what they are. I can see -2 is one of them. So what I'm going to do is I'm going to come over here and I'm going to use synthetic division with -2. I know I have to find 4 solutions. I'm going to bring this down. That's -2, that's -5. That's going to be 10, that's 16. -32 is -30, 60. So now I look at this. I already found a 0 of -2, that's great. I have one of the 4 that I need total. But if I look at this, I can't factor this. I was thinking of grouping, but if I think ahead, grouping's not going to work, is it? Because if I factor a 2 out of here, I'm going to be left with 8x minus 15. That's not going to work. Grouping does not work. Does anybody have an idea of what I could do then? Here's what I can do, guys. Is there another 0 that shows up? What is it? 3. So now I'm going to use 3, and I'm just going to plug it into what's left over here. Because if 3 is a factor of the original, it has to be a factor of what's left over here. So I'm going to do 1, -5, 16, and -30. Bring this down. 1, 3 is -2. -6, that's 10, that's 30, that's 0. So now I have 2 of my zeros. My zeros so far are -2 and 3. How many total do we have to have? 4. We have 2. Here's what we're left with. This is a quadratic function. We're doing that one anyway. This is a quadratic function that I have to solve. You should know a bunch of different ways to solve quadratics. One is factoring. Are there numbers that multiply to be 10 and add to be 2? What numbers multiply to be 10? 5 and 2, do those add to be 2? Nope. Also 10 and 1, do those add to be 2? Nope. So what are we going to have to use instead if it doesn't factor? Completing the square, great choice. I was thinking quadratic formula, but I actually prefer completing the square, so let's do with that. Let's do that way. We're going to take over the 10, it's going to become negative. We're going to take half of this and square it, both sides. This is x minus 1 squared. This is -9. Joey, what do I do now? Take the, so this is x minus 1. Do you know the square root of -9? Yep, plus or minus 3i. So now I'm going to have to take over the 1, so it's going to be positive 1 plus or minus 3i. So my solutions then are -2, 3, 1 plus 3i, and 1 minus 3i. I need to double check. I'm supposed to get 4 solutions. I did. I can look at my graph. I can see I'm supposed to have 1 negative real root, 1 positive, so it makes sense that the other 2 would be imaginary, right? Okay? So again, what we had to do was we used our 1, 0, that worked. With what we had left over, we used the other 0, got it down to this, and then just used completing the square to finish the problem. Okay? Let's do another one of that type. Let's do number 3. What times what would give us x to the 4th? X squared. What numbers multiply to be 49 and subtract to be 48? 49 and what? 1. So this would have to be negative, this would have to be positive. This one I can solve pretty easily. X squared minus 49 has to equal 0. This one, x squared plus 1 has to equal 0. So solving this one, Becky, what do I get on this one? Right, plus or minus 7, right? We got to put plus or minus. Remember that, guys, anytime we take a square root? This one I subtract 1, and I'm going to get x squared equals negative 1. Take the square root. Karish, what's that going to be? It would actually be plus or minus 5. So here would be the 4 zeros. Positive 7, negative 7, positive I, negative I. Does that give us all of our solutions? Yep. So we're good. All right. One more. Let's go down here and do number 7. They tell us that 8 is a solution. They tell us that 3 minus I is a solution. You might know what the other solution has to be? Yep. Go ahead. 3 plus I. So now we have a 8 and these 2. Can we write this as a factor pretty easily? Yep, we can, can't we? Ty, what's that as a factor? Right. So we know what we have to do with these 2 to come up with the factor. What do we have to do, Natalia? We have to multiply them, so we have to find the product, and what else? Sum. So what's the sum, guys, when we add these 2 together? 6. Good, that's easy enough. Product, we have to do 9. That's positive 3i, that's negative 3i, that's 0. What's negative I squared? Positive 1, isn't it? So that's going to be a product of 10. Anybody tell me what that quadratic would be then? Go ahead. Then what? Good job. So that's going to be our function then. That's going to have those solutions. So now I'm going to have to multiply it out. So I'm going to have x to the third minus 6x squared plus 10x minus 8x squared plus 48x minus 80. So simplify by combining like terms. And don't forget to put, let's look back up here. It says F. This is what they want us to name it. You don't need to do this part, but I always check my work, especially if I have enough time on a quiz. I would be checking this if I type it in right. So what I'm going to be looking at is, what's my 0 supposed to be, guys? What's one of the only real 0 I have is what? 8. So I better see that on here. If I don't, yep, there it is. Good. I'm going to check the graph real quick. 8 should be the only real 0 that I see. There it is. Ooh, got a little worried when I went back down, but there it is. And then the other 2 solutions had to be imaginary because we don't have any more x-center stuff. Okay? Make sense? All right. That was a very quick lesson because they're going to be calling you guys down here in a minute. You may also want to read your book a little bit on this section just to kind of see that Descartes rule of signs a little more with these charts. They have some pretty complex charts in the book that are kind of interesting. So make sure you have that assignment, and then we'll go over the other assignment as well. Good job.